Good morning, everyone. My name is Mike Masterson. I'm one of the automation specialists with the Reynolds Company out of the Houston office. And today's user group topic, we're looking at Scalable OEE, or for those who hate acronyms, that's overall equipment effectiveness or efficiency. I've seen it multiple ways. And Nerds, you're going to have to drive since I just realized this is not my deck. And Niraj, you want to introduce yourself as our expert speaker?
Hey, thank you, Mike. Yes, I'm Neeraj Kachadi. I'm the business lead for architecture and software at Rockwell Automation, responsible for Dallas and Houston territories. And I'll be leading the discussion today on overall equipment effectiveness.
Perfect. Now, I'd like to discuss some upcoming events we have. Our next Tech Talk is we're going to look at the highly integrated heart that was introduced with some of our new I/O that we support. That will be on March 24th. We're going to be doing a Rockwell software activation update on April 7th. And then we're going to be working with Win911 and going over their products and some of their new improvements they've made to some of their notification software. So that's what we have coming up for April. And next month's users group, we're going to be talking about machine learning and AI for industrial applications. So please register for these when you get an opportunity. We do record all these. In fact, today's topic is being recorded. But if you ever want to find any of these sessions, feel free. You can find them all on reynoldsonline.com. And with that, Niraj, I'll hand it over to you.
Hey, thank you, Mike. Welcome, everyone. Today's topic is overall equipment effectiveness, or OEE, right? And I want to start this with you may ask yourself, right, does my plant or does my process application need OEE? Well, that is a wrong question. So what is the right question? Right question is, does my facility need to reduce the cost? Does my process applications or process equipment, does it need to be more efficient so that it can produce more within the same investments? So that is the right question. That is the priority for an overall equipment effectiveness. Are you trying to reduce downtime, reduce the unit cost, right? Reduce the cycle variations, reduce overall time? Then you are going to be considering OEE analysis, downtime tracking, machine monitoring, and other process improvements. So what is OEE? What is overall equipment effectiveness? Or put simply, OEE assigns a number to the improvement opportunity, right? It factors in various performance availability factors and also includes quality of your product or of the process output, right? And figures out a number, overall multiply the percentage of all three to get you a number that measures the equipment effectiveness, right? It basically answers the question right here. It shows on screen how much right first time product did this machine produce compared to what it should have produced in an allocated time. Right. Now, in other words, is the piece of equipment effective within its value stream? Right. There are a certain amount of dollars that were paid for that equipment. Does it meet your present or future needs? And how does OEE work? The OEE calculation actually rolls in about 6 big losses into one number, right? That translates to the percentage of product produced compared to what would have been produced in the scheduled time under ideal conditions. Ideal conditions are no downtime, no speed loss, no quality loss. Right? What are these three categories, these 6 big losses? Well, the loss on the availability, or that is basically a downtime, is equipment breaks down, unscheduled, setup and adjustment. So you are adjusting, setting it up properly, whether it works or not. All those are basically downtime for availability, right? And the performance, idling, the equipment is ready, but the product is not going through, the raw materials are not going through, the reduced speed of operation, it's not operating at a full speed or the throughput rate. Then the quality aspect, right? What are the other big loss, right? The product is not meeting the spec, or the reduced quality or reduced yield just because of ramp up time or downtime. So these are the six big losses that you see typically in a production. And in these losses are arranged in downtime, performance, and quality silos.
Let me ask you a question,
Mm-hmm.
Urge. How has this traditionally been or tracked? Has it been a manual process, or have people been automating this for quite some time?
So this is quite a manual process today, as it is. You do during manufacturing, you have seen those clipboards and Excel spreadsheet, and it takes about a couple of weeks at least to collect the data manually and then do the calculations. And in about 3 to 4 weeks, you will come across the detail on what happened. Now, by the time your equipment is running for 3 to 4 weeks at the same level it was running when you are looking at the data, so the improvements you are losing the performance, you are losing availability, quality, as well as you delay the data coming into your hands, right? So that is a big issue today, right?
All right, thanks.
Mm-hmm. So why does an OEE system make sense overall, right? There are three general ways to reduce the cost of an automated process. You reduce the unproductive machine time, right? You reduce the cycle time. Cycle time means basically reduce the stoppages and reduce the waste or scrap. Now, OEE measures the three things that reduce the cost, right? It increases the productive time, so it increases the availability. It can measure the availability. It can give you the insight into performance of a machine, so whether it's running at its peak capacity or not. And it can also give you the quality metric, whether the parts that are produced or the parts, the process output is at the right quality, right? And so OEE percentage is basically availability into performance into quality. And higher OEE means you are paying lower to produce per unit for that specific part. Okay. Now, let's talk about each of these metric, each of these parts of an OEE calculation. Availability. What is availability? Ratio of actual running time to the expected running time. So if your machine is supposed to run in a shift for 8 hours and it is only running 6 hours, then your running time is 6 hours and your available time is 8 hours. So availability actually is quite, it's very easy to calculate that your machine is available for parts to produce. Out of that 8 hours of shift, it was only available 6 hours, right? So in this case, OEE value can be impacted by an availability loss. So even if your performance and quality are meeting 97 and 88%, if your availability is down to only 47%, your machine is actually not available to run, then your OEE value for that machine itself is at 41%, right? How that availability loss manifests itself. That availability loss provides the score of how much an asset that has been operated within its designated production time. So you have, let's say, a compressor, or compressor supposed to work 24/7 because of the continuous process. But if it's down 3 hours, so it was not available for 3 hours, right? That is the time it was not operating. It is an availability loss. Now, when you get an insight to the availability loss, you can also get insight into what are the major events that cause that downtime. are those events happening frequently? Can those events be correlated to other pieces of data? Are there other pieces of information that needs to be collected to give that insight on the availability loss? The second parameter in OEE is performance, right? A ratio of output produced compared to the standard. So actual output versus standard output. Now, the rule of thumb here is the standard output to use is the best output rate known to be produced on that machine, regardless whether that is above or below the design speed. So you should always consider the standard output as the best output rate that can be produced through that machine. Right? If a machine outperforms its best output rate, then the standard output rate is not the best output rate, right? Ideally, it should not happen. Your standard output should be the one that it actually is going to be the one that the machine can produce in an ideal condition. Just to tip again, how it impacts the OEE overall. If your availability is 100%, the machine has been available for 8 hours of shift. Your quality has been up to this limit 96.85%, but the performance, the output of that machine has been running slow. Then also it gives a score. It impacts OEE overall. It brings down the score considerably. Now, I see what's wrong now? What on the performance loss, right? You see the data. You see, yes, I'm losing performance. How can I improve that? What are the data that I need to collect to understand the metrics behind this loss? Well, are there any variations in raw material that is causing the issue? Is there a personnel issue, labor issue that causes one shift to produce or perform better than the another shift in the same product? Right? Is there any other variable upstream of that machine, like if it's a conveyor belt or if it's a valve that has been causing issues? So it gives you ability to find the causes behind this loss. If you see the performance loss, you can inquire, you can ask questions and try to get the data into your historian or into your system to do analytics.
Nuraj, this sort of dovetails into, we have a question like, who is a good fit for OEE, but specifically, what are the differences between taking a look at a discrete manufacturing versus process? Are the indicators the same, or is the data the same we're trying to analyze?
So yes, that is a really good question on the process side. The clear definitions on availability, performance, and quality still apply to process industries as well, right? So here is if there is an unplanned stop or unplanned downtime, then that is an availability loss. Process industries are 24/7 usually, but if there is an untimed shutdown or a trip, that is an availability loss. Now, performance can also be looked in terms of flow or mixing rate, right? What is the theoretical maximum flow or a mixing rate on a process plant, right? It can be calculated as a ratio of actual run rate to a theoretical maximum run rate, right? In terms of calculating this can be expressed as volume produced by runtime or ideal run rate, right? You can have like 1,200 gallons per hour instead of 800 gallons, right?
Mm-hmm.
So then quality, then the third aspect, quality is a little bit difficult, but it can still be measured. Now it's a ratio of good material to all material, right? So in the process of manufacturing, in the end, all the continuous process output are measured for quality through LIMS, right? Laboratory, and also through analyzers, the process analyzers. And that specific quality measurement can be used, or it is used to calculate the quality aspect of the OEE.
All right. Thank you.
Mhm. So how on the quality side, the right first time output divided by the total output, right? So how much produced parts are meeting the quality spec compared to the total output? That is a simple ratio, a measure of quality, right? And anything that is defective, not within the quality specs, they are basically either sent to rework or they are scrapped. It definitely impacts, it has the same weightage as availability and performance. Now, in the quality loss, of course, we can find out what is wrong and what do we do with the data? What is our overall vision? Now, when you have quality, you can always add additional data to find out the reasons for the poor quality. Is there a problem with the machine? Is there data from the quality lab test can be correlated to the production count? Is there deficiency in the raw materials? So all that can be collected. If it's on a process application, then the functionality, the parameters, the loop tuning, that can also need to be corrected or looked at. So in essence, I want to put this together at the end in a very simple way and in this slide, right? What we discussed so far. Overall equipment effectiveness, the key performance indicator. It's one of the key performance indicator, and it takes into consideration the available time, that is shift time, availability, total availability. So availability percentage, running time upon available time, the performance, the total number of products or total number of run rate through the running time, and total quantity that is meeting the quality spec out of the total produced quantity. As you can see here, the runtime, the production at a rated speed, and a good production count, they all combine to make the total OEE number. And the causes for each of the parameters, the causes that affect each of the parameters are also listed on the on this side, the loss causes, right? And this helps us to provide an analysis, right, to the customer from a software perspective. Now, for a customer, when they look at, for a manufacturing plant, when you look at these parameters, these KPIs, you should be able to identify where you can make changes, where you need to invest, your OPEX or CAPEX spending, right, to improve. And so just to give you an example, should changeover time affect my OEE score, right? So sometimes a preventative maintenance or changeover times during shift does affect the OEE score. So how can you reduce the changeover time? How can you schedule your preventative maintenance? How can you schedule lunch and breaks within the shift so that you can improve the OEE score? Right? If a process that does not have operator or enough staffing, does it increase or decrease the OEE score? Those kind of constraints, those kind of visibility, that kind of visibility is critical to improving the overall performance. All right. And that brings to this question, why is OEE so prevalent? Because OEE is a simple performance indicator that everyone can relate to. It is a ratio of good parts produced versus what could have been produced under ideal conditions. So no downtime, no changeover or cycle time erosion, and no scrap. Right? So OEE means actual versus ideal. You are comparing to an ideal model what is happening currently. And we are trying to push towards ideal all the time. And the other aspect is it can be applied to any machine, any equipment in any industry, anywhere in the world. So it is agnostic to the platform. It is agnostic to whether that machine or whether that equipment is fully automated or the data is collected completely or not from the control system. It is agnostic to that. That this OEE KPI or key performance indicator is agnostic to the method of collection. It is also agnostic to the geography or to the platform.
We do have a question that was thrown out. Is there how do you quantify an OEE solution in terms of dollar amount? I know I might have skipped ahead on this one, but is there a specific model to do that, or it varies on your applications?
So that is a really good question, and I will address that in one of the slides as well. But I can give you a preview a little bit. So think about an OE improvement, right? So if you are running a plant that has a specific X dollar number of amount as an output. So if you're running a plant or a process plant and you are selling, let's say, ammonia that's going out and the plant is generating revenue for the company, and the OEE for that plant is about 70%. Improvement, let's say, for example, $100 million. And if improvement of 1% of the OEE can help plant improve the throughput, the output, and reduce the cost, and overall savings would be to the tune of $1.2 to $2 million, right? So that the whole process is identifying how much time it takes for a customer today, or it takes for a plant today to do and propose the changes so that they can either realize the savings through using the capacity, or they can increase the throughput, again, through increasing the performance, right? So it can be both. It can be savings and higher revenue. It can be both. You can you can justify the OE implementation or scalable OE implementation through savings or through a higher revenue. It depends on the plant's or company's focus. If they have a capacity problem, then the revenue would be the ideal. If they have availability problem, or if they are looking to reduce the cost of operations, then it's savings. You can justify it through the savings it will bring into the plant.
Okay, thank you.
So now, if you are running normally and meeting schedules, you may think there is nothing to improve, right? Well, my plant is running fine. My operations are running fine. I'm meeting my goals for production. I'm meeting my goals for, right? I'm meeting my goals for labor. I'm meeting my goals for machines, maintenance, everything. It's all running on schedule. But here is the thing, because the target is based on schedule or present demand and not on theoretical capacity, you might be running at a greatly reduced speed, or you might be running at a reduced level of performance and reaching your target, right? So now when a focus team applies the OE to each step in the production line or a plant or each machine, they can usually readily identify opportunities to reduce those 6 big losses that we discussed. All right. So now, when we talk about a theoretical capacity of equipment, think about it in this manner, that if an equipment is supposed to produce 100 parts an hour and you are producing 50 parts an hour today, so you do have theoretical capacity of 50 more parts, and you can sustain the growth of the company, right? But if you do not look at the OEE, you would not know that. And in that case, if somebody will ask the plant manager, hey, can you take on more capacity in production? We are expanding today. The plant manager would not be able to give that answer without data, that how much capacity he is able to meet. But if you have an OEE with OEE data with you, that we are operating at 50% OEE, and we can definitely take 10 or 20 more percent capacity to increase our OEE to 70%, then it will be it will save a huge amount of capex funding for the company, because now they can improve, they can actually grow without spending capex dollars for that plant, right? Without buying additional equipment, without hiring additional people, they can just use what they have and increase the capacity. So OEE number, or a KPI, is very critical to know how much your plant has capacity to grow, right?
Okay.
Now, you asked a great question, Mike. There was a question that came in about how it is gathered currently. And most of us have worked, or at least have had experience working in plant where we would see all the key performance indicator data collected on a clipboard right at the production line, or in a plant, right? All the readings, analyzer readings are there, kept in those documents, and they are entered into Excel, and they are updated. In over a period of 2 weeks, you have a rolling OEE, or key performance indicators, getting collected and sent out. This is how most of the plants, most of the facilities operate today. And that is tedious, time consuming, and expensive, because there are people who are being tasked to do that only. So it is not really productive. They are not putting effort, they are not spending time in production. They are spending time in collecting data, right? It has to be, so the best way would be to collect automatically, right? Then data is stale. So it's about 2 weeks after the fact, you are looking at the metrics, right? It is not detailed enough. So there is no insight, there is no context to the data that you are getting, right? Your machine was not available, but do you know the reason why it was not available? Why it was down for so much time, right? So there is no context to what happened. What can be done, can be prevented, right?
Okay.
Now, what is better? How do we improve that? Well, with the Scalable OEE, with the software-based OEE solution, you can collect and store performance data that is not on clipboard, not in Excel, but directly from control system using existing PLC and HMI. And this, using existing PLC, HMI, or control system, it typically has the data that you need, because guess what? They are the ones that are controlling. Those systems are the ones that's controlling the machines. They are looking at each piece of material that is going through it, right? Measuring temperature, pressures, or counts overall. They can provide a lot of data that is required for OE, like production counts, pass or fail on the quality, right? Machine cycle times, when the machine was stopped, when it started up again, why did it stop, the fault codes on the machines, right? Why did it stop? What happened? What were the alarm codes? Unproductive time, so it is idling, so it's waiting for material to come in, right? So all those data, all those pieces of data are already there in the control system, right? And they are reliable and they are accurate and precise because it's collected directly. There is no human being trying to read the data and form his own or his or her own opinion on it, right? And it also analyzes, it can help analyze the individual operation of a line, machine, or overall as a whole plant. So the data collection is automated. Now, what do you do with the data? So that data feeds into those equations, those business logic for OEE and key performance indicator. It analyzes the data. How are we doing? What is happening right now? You get the instant dashboard, instant feedback, right? If you look at an OEE today that is done on paper and Excel, that data, that is a snapshot in time. And that time was about 3 weeks back. But if you want to know what happened after that, so let's say 3 weeks back data, you have the time snapshot. What about 2 weeks back? Do you know 1 week after you took the data? Well, guess what? You will have to wait 1 more week before you can see that that snapshot, right? With an automated data collection, you can actually see the snapshot immediately and can start making process improvements. But once you make the process improvement, you can also see the feedback, right? So immediate feedback from that improvement, whether it has worked well or not, how it is performing, how your changes are performing. And you can continuously monitor and change that impact. One of the questions we always get is where to start. This is really great. OEE key performance indicators are really great. It is a great tool, great ratios. How do we start? How do we begin to implement it? Well, we recommend what we call a scalable OEE. So what that means is first, visualize. The first step in scalable OEE implementation is first to see the data, first to see the indicators, the key performance indicators for OEE. We have to collect the data. We have to connect the data, connect to the assets to collect the data, right? So if your machines, if your equipment is not connected and it is lacking in the data, then we have to implement those connections. So networking is the critical part of it. You have to network the machine just internally, collect the data. Right? When you see the data, some of the performance indicators and some of the insights would be obvious, right? What are the top faults that are happening? Right now, you are looking at top alarms whenever there is a alarm and that stops the machine, you can see that how many times it has been triggered in last 1 week. And that has caused a certain amount of availability loss, right? Now you are looking at the data in real time. So you can prioritize which machines are causing the most downtime in a line. Right? So you have a line of 4 machines. Now, machine number 1 is showing that it is at 85% OEE, but machine number 2 is showing that it's at a 50% OEE, and machine number 3 shows 50%. But now, do you know which machine actually is the cause? So you can identify that just by looking at the data. So that the first step is to visualize that. The next one is benchmarking. Right? So when we talk about benchmarking, we are talking about adding assets and comparison between those assets, correlations, right? You get a multi-line view for the whole plant, multi-machine view, and you are correlating non-production data. So what is the non-production data here? The shift data, the maintenance data, all right, the safety data. you are correlating those. Right? When you correlate production, when you correlate and look at insights from multiple data sources, you can identify which resources, which labor resources are working at a peak performance versus which are not, and what is causing that. Right? There might be a safety incident that has happened in a couple of days, and that might be reducing down your machine quality, the OEE factor as well. So that is benchmarking. Now you are collecting all the data from labor side, the safety, the maintenance. Right? Now optimize. Now this is the last stage. This is the stage where you will get the best value because you are optimizing the performance based on complete data analytics. Right? You can establish a baseline environment and apply advanced analytics tools to give you a prescription, right, to provide to improve the OEE and improve not only the machine OEE or the line OEE, but the performance of the facility overall. Because in step number 2, we are connecting to the other systems, right? Now, when we bring in data from other system and how it correlates with the production system, it does set up for analysis and optimization.
Let me ask you, how are these generally deployed just internally at the facility, or quite often are you bringing in outside consultants?
So outside consultants are brought in as well. And so in a facility, there is like I showed, right? There is a version of OEE already going on. They are measuring availability. They are measuring performance, right? All the labor resources are paid on the performance. And there is a segment or a version of OEE going on, but it does not take into consideration all the aspects. Now, a consultant's value to a manufacturing plant is that they will bring the overall vision or what can be achieved, right? They can show them what they are missing, what is the white space in their OEE collection or their OEE strategy, right? Or their key performance indicator strategy. What are the white spaces? What are the missing blocks? And that's the value for a consultant going in there. And consultants are welcomed. They're usually OEE or the key performance indicators would be one of the first steps to start from. And here is, and your question was right on time, because here we talk about where do I start, right? I am not collecting any information, want to start tracking OEE. That is the most, if your plant or if your customer, end user customer is at this level, you basically start identify a machine or a line for a proof of concept to build an early provable win. So what I mean by early provable win? Well, you identify a machine, you identify a line, and the whole concept from start to finish, you look at the data, you connect the data, you connect it to a dashboarding tool and an application engine that runs the calculations on OEE and show them the data. Here is what this machine is doing. Here is how many times it went down, and here are the reasons why it went down. And if you improve on these reasons, you will get better throughput, or you will get better OEE, and better OEE will give you either good quality parts or more parts produced, depending on where the deficiency was. The second is, hey, I got some data like a maintenance CMMS system or a lab system, and I want to correlate with OEE. Or then implement the benchmark solution where you connect the assets you connect the dashboards and OEE data, and then you start correlating and pulling in the data from maintenance system and lab system as well for quality and maintenance side, right? And now you can have all the data displayed together for additional insights. And the third, the benchmark, the optimization. So they customer has historian, they have other data resources as well in the plant. They want to start the move to a predictive KPI, right? So now they want to predict whether their OEE will go down or up in future. Now, so then that side, we basically, you are already an advanced user of OEE, right? You already have OEE, you know what OEE is. Now you want to use that data, that OEE data, to predict what your future state would look like. And that is where you would basically implement our last step on advanced analytics and AI to connect, collect the data, run, implement AI algorithms, and you can predict and generate predictive KPIs for your facility or your machine or your line, depending on what happened in history, how it correlated with the maintenance cycle or with the labor cycle. Well, in the end, what is the payoff, right? We talk about, there was a question, Mike, you asked, how do we justify it? What is the payoff? So this is a metric right here on the side that I was talking about a little bit. But let's say just 1% increase in efficiency in a plant that is producing revenue worth $50 million a year, running at a 50% OEE is $1 million per year increased in production. So think about this, the impact, right? For a facility that is producing, that is generating or supplying of parts producing $50 million revenue per year, if they improve their efficiencies on OEE by 1%, they can improve that their revenue by $1 million, right? So that increment in the revenue of $1 million, what is the cost that will just help them justify it? Now, it's not the same. It's not that the OEE will not go below 50, but if you are able to see that, if you are able to improve just 1%, think about it, how much they would gain by improving 2 or 4%. To see that revenue, to be able to invest in improving the operations, you would need to see the KPIs first, right? And that's where the OEE's value is. It enables the facility managers, it enables the plant managers to be able to see and understand what is going on in the plant and where they need to spend, right? So it decreased manufacturing cost, less overtime, reduced labor cost, decreased overhead cost. So now the folks going on the clipboard and collecting data, that doesn't need to happen. Deferred capital expenditure. So now you can understand the capacity of your production line, and you can say, well, I have the capacity. I have capacity for taking in the growth that that company is going to do, right? And also increase the overall capacity in the same amount of time. Any questions, Mike?
No, not right now.
Yeah, perfect. So in the in the conclusion, I want to say this, that automated performance monitoring does enhance the business result and reduce the cost, right? One thing I want to talk about in the conclusion, that OEE by itself is not enough, right? So OEE is one of the key performance indicator in a plant. It is one of the key, but there are other key performance, key indicators as well. that works with OEE to identify the overall performance, right? The detailed event data is also required to understand the root causes. So let's say if you just do the OEE implementation, so you get the availability, performance, and quality analysis done. Now, if there is a requirement to look at the root causes of the quality issues, then you definitely need to implement a system that will go and enable the root cause detection, right? And the other aspect is on the when we talk about OEE, it does not take into consideration the total cost of ownership of an equipment, right? So if you have an equipment that is running 24/7 compared to an equipment that is only available or running 16 hours a day out of 24 hours, then the OEE of the 16-hour equipment or total cost of ownership would be different than the one that is running 24/7. Right? So there are certain other parameters that go with OEE, but OEE is one of the key parameters or key indicators that is required, and that can give a huge and valuable insight into your performance of a facility. And it uses the current existing control systems that's already installed and working. Okay. So with that, any questions?
Not so far. You seem to have covered all the bases on this. And I do appreciate that you didn't go, you kept this generic and not just specifically a Rockwell solution. So I think the majority of us found this very informative.
Perfect.